All right. So, hello and welcome everyone. Welcome back to this Pradhan Academy. So today we are live again, and today we're going to discuss about the important chapter of matrix and determinant. Right. So we are going to discuss the chapter especially for the JEE Advanced examination. Right. So in today's session, we are going to solve the questions, and along with that, we are also going to revise the chapter especially for the upcoming exam. All right. So let's get started. So before we start this chapter, I would request all of you to please go through your basic notes and have a good revision of these topics. Okay, so the best way to start on this recap is basically by going through your NCRT as well as your NCRT exemplar, right? So I would request all of you to please go through your NCRT as well as NCRT exemplar, and once you're done with that, you can start to watch on this particular topic over here. Okay, so we are going to discuss and revise the questions from the previous year paper, and along with the questions and revision for that particular questions, we are going to also recap and try to understand how different types of questions can be framed there for the upcoming examination. All right, so are we ready to start? Just give me a thumbs up if we are ready to start. Right, that's great. So okay, so a very good morning to all of you. Right. Okay, that's great. So today before we start this session, I'm also going to announce you a very important topic. Very important thing is that like we are going to start the live online batches. Ashutosh Anand, hello. Hello Ashutosh Anand. How are you doing? So yes, so we are going to start live online batches. Okay, very soon. Please contact on this number in order to get any update over this batch. Okay. So if you want to get any update over this batch, how we are going to study, what is the schedule of this batch, everything, all the information is going to be there in this particular. Okay, so just contact this number, okay, and get connected with my team in order to if you want to get a subscription of this batch, you can always purchase this batch. Okay, so we are going to come live with this particular batch very soon. So the enrollment is on right now. Don't forget to enroll. Okay, so if you're preparing for the upcoming JEE Advanced 2026 and 2027, then this is a very beautiful opportunity for all of you to learn from me and my team. Okay, so don't forget to enroll to this batch. Okay, just contact this particular number and start your enrollment. In case you want to get more updates regarding the batch and schedules, you can always join our Telegram channel that is in our description box. Ashu Gupta, sir, one of my friends want to prepare for an exam, but he is not good at study. Suggest some less hard exam for him. Um, See, if you look for less hard exam, I would definitely say you can. There are some state government examination that are also being conducted, right? So maybe your friend can try out that. Okay, so that is something that your friend can try out. Some state government examinations. Okay. So that are much simpler. Also I would suggest you trying the bit side examination. Okay, that is also very easy, right? Okay, so with this work, let's get started. Okay, so today our goal is to discuss the previous year questions of JEE Advanced, and along with that we're going to practice the MCQs and the numerical type questions, and we're going to get ready for the exam. Okay, so that's it. So here we are, starting with the very first question, and the question is on your screen. All right, so let's give a thought on this particular problem. Okay, so I would request all of you to please just stop the video over here in case you want to solve it by yourself, or maybe you can give it a try. Okay, so the very first thing in order to get started on this question, it says that we have been provided with the matrix over here. Okay, so let's try to analyze. The matrix that is given to us is basically having the following entries as follows, right? Over here, now it is said that the value of a matrix expression, that is 8 to the power 7 minus beta minus 1 times a to the power 6 minus beta a to the power 5. And this particular matrix is a singular matrix. So in case if you forget, a singular matrix is such a matrix whose determinant is basically equals to 0. Okay, so if any of a matrix is determinant is equal to 0, we call that particular matrix is a singular matrix, right? So this is very, very important to understand. Okay, so if this is a singular matrix as mentioned in the problem, if this is a singular matrix, then the determinant value of this particular expression or matrix expression should be equal to 0. That is determinant of a to the power 7 minus beta minus 1 a to the power 6 minus beta a to the power 5. This particular determinant should be equal to 0, right? So this is basically the expression that you need to solve it out. Okay, so let's see how we figured this part out. So if you just simplify this expression over here, let us take a to the power 5 as common. So if you just take a to the power 5 as common, then it is going to be a square minus beta minus 1 times a minus beta identity matrix, and that is what, and determinant of this is equals to 0, right? So this is can be simplified much further as determinant of a to the power 5, and then we have the determinant of a minus beta minus 1. Okay, so what I'm trying to do is club the a part together. So over here it's going to be like a minus beta I times of a plus I, right? So that is how you can factorize this part out, and this particular determinant is equals to 0. So from here you will basically have a determinant equation which is equals to 0, right? Now if you try to figure this part out, what you're going to see is that if I try to find out, so from here if I try to find out what is the determinant of a, so determinant of a is going to be equals to, so you can just try to find a determinant of a over here. It is going to be equal to beta times it's going to be beta times 0, and then 1 times minus of 1, right? So that is going to be give you the determinant value as equals to minus of 1. So determinant of a is equals to minus of 1. So from here, from this expression, you're going to get this a plus entry matrix, and the determinant of that, let's try to find out that the determinant of that, if you try to find it out, so I just solve it on the next page. So it is going to be like beta plus 1 0 1, and then 2 2, and minus of 2 3, sorry, this will be 1 over here, and this will be minus of 1, and the determinant of this is equals to, so if you try to find it out, this determinant is going to be equals to just equals to minus of 4. Okay, just equals to minus of 4, and therefore you will also see that determinant of a is not equal to 0, and determinant of a plus identity matrix is also not equal to 0, which leaves us with the only option is that we should have determinant of a minus beta I should be equals to 0, right? So that's what we have, that is a minus beta I, determinant of that should be equals to 0, right? Now if I try to figure this out, the determinant is like 0 0, 1 over here, and then 2 1 minus beta, and then this is going to be minus of 2, this is going to be 3 1, then minus 2 minus beta, and determinant of that, right? So that should be equal to 0. So if I just try to solve this part out, you're going to get 2 minus 3 beta is equals to, that should be equals to 0, and on solving this we'll get 3 beta 3 beta is equals to 1, which basically leaves us with beta is equals to 1 upon 3, and ultimately we have to find out the value of 9 times of beta, and which is basically equals to 3, right? So that is the numerical answer that we're going to have it over here. I hope this is clear to all of you. I hope this solution is clear to all of you. In case any part is not clear, you can definitely let me know. Okay, so I will be going through a live chat. Just let me know in case something is not clear. I will try to repeat it again. Great. Do just let me know in case something is not clear. Okay, so I hope this is clear to all of you. So are you all getting the answer as 3? Just let me know the answer you're getting. All right. So once you're done with this particular problem, let's move to the next problem then. Okay. So let's move to the next problem. Okay. So we have a bigger part of problem, and that's what we're going to solve over here. So it's a problem which combines both matrix indeterminate as well as the 3D geometry, right? So this will be quite a good question to recap on the both the topics together, right? So let's see how we go about solving this problem over here. Okay, so first and foremost, it's mentioned that there are 3 system of equation or linear equations as mentioned. Okay, and it says that this particular system of equation is consistent, right? And then it says that this determinant of M represent the determinant of this particular matrix M over here, right? So the matrix M is given over here, and it says that let P be the planes containing all those alpha, beta, gamma points for which the above system of linear equation is consistent. Okay, so for consistency of this particular system of equations, the alpha, beta, gamma values, and it says that P is the plane which contains those alpha, beta, gamma, and d be the square of the distance of the point 0 comma 1 comma 0 from that particular point, from the particular plane P, right? So how we are going to figure out and solve this particular problem over here? Let's try to understand. Okay, so it's a very interesting problem. First and foremost thing that you have to check it out is that you have to work on the consistency of the system of linear equations over here, right? So what I'm going to do is that I'm trying to figure it out whether. And interestingly, if you try to see the third equation, let us call this the number 1, number 2, and number 3. Interestingly, what you'll find it out that if I see the third equation over there, right? So, and then minus gamma minus 1, that I can write it as some 4x plus 5y plus 6z minus beta, right? Minus beta, and let's say this is a times this plus some b times x plus 2y plus 3z minus of alpha, right? Minus of alpha. Now, why I'm writing this? Because it says that this system of equation is consistent, right? Is consistent. So if I just try to compare the coefficient of the x, y, and z on both these sides, so from there, what I will get is that 4 times of a plus of b is equals to 7, and I will also have 5 times of a plus 2 times of b is equals to 8, right? And then you solve these two equations, and there you go and get the value of a as equals to 2, and then you get the value of b is equals to minus of 1, right? So that's the two values, right? So that's the two values you will get over here for this particular set to be a consistent, right? So from there you will get gamma minus 1 as equals to some minus a times beta minus alpha times capital B, right? So therefore from this particular thing, what you will see that it's a variable in terms of alpha, beta, and gamma, and it's kind of the form is minus alpha minus gamma plus of 1 is equals to minus of 2 beta minus of 2 beta plus of alpha. So therefore we can write it as alpha minus 2 beta plus of gamma is equals to 1, and this is involving the variables alpha, beta, gamma. So therefore this is my required equation of the plane. This is my required equation of the plane, right? Required equation of the plane. So therefore we have the equation of the plane P. Okay, so we have the equation of the plane P. Now it's very simple to us. Now we just have to find what is the determinant of matrix M, right? So determinant of this is going to be alpha 2 gamma, and then we have beta 1 0 minus 1 0 and 1, and we check the determinant of this is going to be equals to alpha minus 2 beta plus of gamma, and this particular value is equals to 1. So therefore the numeric value of the determinant of M is equals to 1. Is this part clear to all of you? Is this part clear? This is very simple. See, first and foremost thing that is mentioned is that we have to find it out the condition of consistency, right? So if we see over here the system of equations, and then we look at the consistency condition, and from there I was able to express this first two in the third equation in terms of the first two, right? So from there you will understand since how to solve this particular problem, right? So from there you definitely get the locus equation of alpha, beta and gamma, and which is basically nothing but the equation of the plane. All right, is this clear to all of you? Is this part clear to all of you? Do let me know. Is this part clear to all of you? In case something is not clear, you can always ask me. Okay, and if you're watching the session after the live class is over, you can always put your questions in the comment sections. Okay, so don't forget to do that. Okay, just don't keep any questions in your mind. All right, now all right, so in the next part it says that D basically represent, so there's a next question also. Here we have to basically find the value of D, right? So if we look over here, D basically represents the square of the distance of this particular point, right? So we have the plane or the equation of the plane, that is x minus 2y plus z is equals to 1, right? That's the equation of the plane. Right, so once we have the equation of the plane and we have to find a distance from the point, let the point is basically 0 comma 1 comma 0, and we find out this particular distance or perpendicular distance, right? And it says the distance, the square of this distance is basically given as D. Okay, so the square of the distance can be simply find it out as very simple, right? So actually square root of this, because D represents the square of the distance of the point, so I should write it as square root of D is the distance, okay, and D is the square of it. So maybe you can try it out in your way, whatever you understand, but yeah, that's it. So from here it will basically equals to minus of 2 divided by square root of 1 plus 1 plus 4, and take a mod of it, and sorry, there will be one more minus of 1, right? So this is going to be equals to 3 upon square root 6, 3 upon square root 6, and if you just squared both the sides, the D, that is what we have to find out. So D is going to be equals to 9 upon 6, which is nothing but 1.5. So the value of D, you will find it out as, so over here the value of D that we get is basically 1.5, right? So the value of D is basically equals to 1.5. So that's a very interesting problem that was asked in the previous year JEE advanced problem. Okay, so it was a comprehension type of question, so you have to comprehend and understand. Okay, so once you're able to comprehend and understand this particular thing, the value is going to come out very simple way. Okay, so I hope this is clear to all of you. Is this part clear to all of you? Is this part clear to all of you? Please do let me know if you have any questions regarding how did I find the equation of plane, you can always ask me. Okay, so how did I find the equation of plane? You can always ask me. So what I did is that since alpha, beta, and gamma are the unknowns, so I tried to figure out what is the locus of the alpha, beta, gamma over there, right? So that's how we basically figure out that the equation of the plane, right? Is this part clear to all of you? Just give me a confirmation. Is this part clear to all of you? Yes, no. All right. So if this part is clear to all of you, we can proceed with the next part. Okay. Now, before I proceed for the upcoming session, upcoming parts, I would like to talk about quickly on some of the important things, right? That is very, very important in case you basically need to understand as well as work on it. Okay. So one of the very interesting problem that is basically generally asked up is the orthogonality matrix. Okay. Sometimes this is very, very important. Orthogonality of matrix, and there are questions that has been asked on this particular topic very, very explicitly. Okay, so don't miss out on this particular topic. It says that if you have a square matrix, let's say the square matrix is a non-zero square matrix, and you take multiplication of a and a transpose, a transpose. Okay, a transpose, and that is equals to identity matrix, then we call this matrix as orthogonal matrix. Okay, so these kinds of matrix are generally called as orthogonal matrix. Okay, so it's a very important concept, and sometimes there are a lot of questions that has been asked on this particular topic, right? Now, apart from orthogonality, I also want you to also discuss about the adjoint of a matrix. Okay, now this is also very important to discuss about adjoint of a matrix. Okay, now what is basically mean by adjoint of a matrix? So if I have any square matrix, the adjoint of a matrix basically denotes the transpose of the cofactor matrix. Okay, the transpose of the cofactor matrix, where your cofactors is basically nothing but -1 to the power I plus j of the minors. Okay, so once you find that the minors for that particular element and you multiply it with -1 to the power I plus j, this will give you the cofactor. Okay, this is called the cofactor. It's very important to understand this particular terms. Okay, so this is the cofactor. So once you calculate the cofactor, and this is called the minor, right? So minor is generally obtained by deleting the particular row and column concerning that particular element. Okay, so once you calculate this cofactor and the matrix you made, and if you take the transpose of that, that is basically called the adjoint of that particular matrix A, right? Now what is more important to look into this is the properties. Okay, so the properties of adjoint is very, very important. Okay, there are a lot of questions involving these properties, so it's very, very important. And the most important property that you need to remember is that if you have any square matrix A and you multiply with the adjoint of that, it's basically equals to determinant of A into identity of order n. So whatever order your matrix is, you're going to have this is a very important result, right? Okay, I hope you remember this particular result. It's very, very important for your exam. Okay, now from this result only we try to calculate what is the inverse of matrix. Okay, so in case you are wondering how to find out the inverse of a matrix, we generally find the inverse of matrix from this result, that is A inverse is basically given as adjoint of A divided by determinant of A divided by determinant of A, right? So that's how we find the adjoint inverse of matrix. Okay, is this part clear to all of you? Just let me know if this part is clear or not. right? So this is a quick recap about the concepts. I am pretty sure that you know about all these things, right? So let's move to the next problem then. Okay, so this is a very interesting problem. It says that the trace of a square matrix is defined as the sum of the diagonal entries. We already know this, and it says that we have a 2 cross 2 matrix as A. Okay, so let's say that the A matrix is consisting of this of the following entries. Okay, so it's a 2 cross 2 matrix like this, right? And it says the trace of A is basically given as 3, and it is said that the trace of AQ is basically given as minus of 18. So trace of A is 3 and trace of AQ is given as minus of 18, right? So from this first equation I will get A plus D as equals to 3. I will get A plus 3 as equals to 3 as my first equation, right? Now I have to also figure out what is AQ. So in order to find out AQ, it will be like A square into A, right? So let's try to figure out what will be AQ, right? So if we try to see what will be A square, so let's try to first of all find out A square. And in case, okay, so what I can also do is that I will be replacing one of the variables. Okay, let's say I replace this D because I already have an equation with A and D, so I replace this D over here, right? So it will be A, B, C, and this I can write as 3 minus A, and then I multiply with A, B, C, and 3 minus A, right? So if I take the product of this, and we are going to get the result as A square plus BC, and then over here we will have AB plus 3 times of B, and then minus of AB, right? And then this will be AC plus 3C minus AC, and this element will be this element will be BC plus 3 minus A whole square, right? So that's what we will have. And then from this result you have to find out our AQ. So AQ will basically A square into A, and that element, that particular matrix is going to be, so we need to be only concerned about to find it out the trace, right? So the diagonal elements are the only element that we need to be concerned about, and we have to basically find out the trace of AQ, and that is basically equals to minus of 18, right? So if I try to find out the trace of AQ, and that will basically come out as A cube, small a cube, plus ABC plus 3 times of BC plus 3 times of um, another 3 times of BC will be coming up here, right? Plus 3 times of BC, and then we'll have minus of ABC plus 27 minus of 9A plus 3 times of A square minus A cube minus 18A plus 6A square, right? That's what a big expression that you're going to have it over here. Now if you simplify this part out, we are going to have it as 9 times of BC plus 27 minus 27 A over here, and then plus of 9 times of A square, right? Which is basically given out as minus of 18, right? That is the stress of AQ. So if you just simplify this part out, you're going to have it as 3 times of A minus A square minus B into C is equals to 5, right? So from this, if you need to find out what is the determinant of A, that is going to be equals to only 3A minus A square minus BC, and which is nothing but equals to 5. Therefore we get the determinant for the matrix A, which is a 2 cross 2 matrix, and that is basically equals to 5. I hope this part of the solution is clear to all of you. Is this solution clear to all of you? Yes? No? Please let me know if this part is clear or not, right? I hope this solution is clear, right? So you must be also getting the answer as option number of as numeric value as 5. Is this part clear? Just make sure that you carry out these calculations correctly, okay, because this is a lot of calculations. Okay, I'm just writing the direct calculation expression over here. Okay, so it might be difficult to catch up. Maybe I would say that please try it out step by step. Okay, just have some patience and try to solve it step by step. What I would say that you don't need to perform the entire matrix multiplication over here, but instead of doing the entire matrix multiplication, just be careful that you need only this first elements and the diagonal elements, that's it. Okay, because that will actually work out. So in order to get diagonal elements, just multiply this element with this element, right, and this element with this element, right. So that's what will give you this result. Okay, so that's why I wrote this result over here. Okay, so this is going to give you the result over here, and if you just find it out, this expression, so from this expression, once you find out this particular expression, it is nothing but it is basically the determinant of A. It is the, this expression is basically the determinant of A. Okay, all right. So just let me know if this part is clear or not. In case you have any questions, don't hesitate to ask me. Okay, please don't hesitate to ask any question you have. Just ask the question. Right? Is this part clear to all of you? Is this part clear to all of you? Just to make sure that you are not just copying down the steps, and also you're also understanding, right? So please make sure that you understand and then you copy. All right, so with this I would be pretty much done with the interesting parts and questions about matrix and determinant, but I would like to leave some question as a homework. Okay, so I would ask you all students to practice this question. This is the first homework. Okay, just try to solve this question, and this question is very interesting because it involves binomial theorem, so the binomial coefficients into the determinant concepts. Okay, so this is a very interesting problem, and I would request all of you to please go through it. Okay, and let me know the answers in the comments. Okay, you can let me know the answer in the comments. Okay, so once you're done solving this, you can also let me know the way you solved it, okay, in your comment section. Right, so this is the first question homework, and there is one more homework problem. Right, so there's one more homework problem. Okay, just try to solve it. Okay, in case you're not able to get any of this, you can always let me know in the comments. Okay, that you're not able to get the question, I will try to help you out, and I will provide the handwritten solution in the Telegram channel itself. Okay, so and also don't forget to join the Telegram channel, the link is in the description. Okay, so there are certain few more, so this is the last homework problem that I would like all of you to please give it a try. Okay, this is a very interesting problem, and you will see that because of having a lower triangular matrix like this, the matrix multiplication is much simpler. So in case you have a triangular matrix, okay, so in case you have a triangular matrix, it's very easy to do higher order multiplication. Okay, in case you have a triangular matrix, it's very easy. Okay, so make sure you note this and keep a note of this, right? So try to solve this up. If you're not able to get it, don't worry, I'm there to help you out. Okay, but the as a rule of thumb, it's very important to just try to solve this, try to get a hand dirty. Okay, maybe if you just try to figure out to perform this matrix multiplication over here, you might be having difficulty, you might not be having difficulty because it's a triangular matrix. Okay, so that is something that is very interesting. There is a pattern in element that you need to be repeated. Okay, and that is something that you need to find it out with doing this particular solution questions over here. Okay, so it's very important to solve this question by yourself because you are actually getting ready for the upcoming examination. Okay, so that's what you're training for. Okay, so with this part I would like to end our session over here. Okay, so please solve these questions and do let me know the solutions you are getting with the answers in the comment section. I'll be very happy to reply back to your comments. Right, so with this I take a leave and thank you.